Welcome back, students, to Unit 11, Acid-Base Chemistry. Today we will be talking about electrochemistry. In this class, we have talked about chemical reactions, and we've classified chemical reactions as there being 5 types of chemical reaction. These being synthesis, decomposition, single and double replacement reactions, as well as combustion reactions. However, that's kind of a juvenile approach to types of chemical reactions. In second year chemistry, we classify chemical reactions as falling into 3 types. Acid-base reactions, which we have just discussed in this unit, combustion reactions, in which oxygen produces one or more oxides, and redox reactions, where electrons are transferred. And it's those transferring of electrons that lead us to electrochemistry. The work specifically of Galvani and Voltaire. Voltaire said that redox reactions are reactions in which one element gives up electrons to produce something with a more negative charge. So the element that gives up electrons, the element that loses electrons, is said to be oxidized. It becomes more positive. While the other element that gains those electrons and becomes more negative is reduced. You can remember it by the phrase oil rig. Oxidation is a loss and reduction is a gain, as long as you remember that it is electrons that are gained or lost. You can also remember it by the phrase Leo the lion goes grr. A loss of electrons is oxidation, a gain of electrons is reduction. With that being said, you're now able to answer your first note quiz question. Go ahead and pause the video and record your answer in the back of your packet. Enter it into the Google form at the end of the video. As this phenomenon was documented by Galvani and Voltaire, we carry these reactions out in what are called galvanic or voltaic cells, or what you now know as batteries. For example, the Duracell battery powering your calculator is actually commonly referred to as a copper top, because it is a copper electrode separated from a zinc electrode by a salt solution and connected through a wire. The zinc loses 2 electrons and is therefore oxidized, and the copper gains those electrons and is therefore reduced. Capturing those electrons along a wire is what is powering your calculator. You can actually cause these reactions to run backwards, as is the case with your car battery. Your car battery works off of the fact that metals can form metal ions. For example, lead is oxidized and becomes lead 4+ ions. However, if given a charge from your alternator, those lead 4+ ions can go back to being lead solid. So if you were to cut your battery in your car in half, you would find a solution and lead plates that are constantly being eaten away at as lead is used up to build up that charge and built back up as the alternator causes the reaction to run backwards. With that being said, go ahead and answer the second note quiz question in the back of your packet. Record your answer and enter it into the Google form at the end of the video. In order to determine if something is oxidized or reduced, we have to provide it its oxidation state or charge. Oxidation state or oxidation number is simply the charge that that element has, and there are some rules to naming it. In this class, we have already talked about charge and oxidation state. In the beginning of the year, we talked about how everything in the first column, the alkaline metals, are always a +1 ion. The alkaline earth metals, column 2, are always +2 ions. And then for the nonmetals, starting from the halogens, we said halogens are always -1, so fluorine's entire family is a -1. The chalcogens, oxygen, sulfur, and selenium are always -2. Nitrogen and phosphorus, we said, were always -3. And for the vast majority of this year, that is true, because for the vast majority of the time, that is true, that those elements have those charges in oxidation states, especially in binary ionic compounds. However, that's, again, a slightly juvenile way to put it. In reality, group 1 and 2 metals are always +1 and +2 respectively. However, the nonmetals can do some weird things, as nonmetals have an empty d orbital that they can put electrons in or take electrons away from. So fluorine becoming fluoride is always -1. However, chlorine, bromine, iodine, and astatine, the other halogens, all can have various oxidative states. In fact, it is only fluorine that is ever truly always -1. Chlorine, bromine, and iodine can change. Oxygen is always -2 with a rare exception, but sulfur and selenium can have fluctuating oxidative states. And nitrogen and phosphorus, they're a mess. So in terms of determining the oxidative state for an element, we will follow some simple rules. First off, anything elemental is automatically 0. The oxidation state or oxidation number for group 1 and 2 metals are always +1 and +2 respectively. In this class, we will assume that oxygen is always -2, and fluoride is always a -1. Altogether, the sum of all of these oxidative states for any compound has to be 0, or if we're dealing with an ion, has to equal the charge of the ion. So turn your packets to example 10, and let's assign some oxidative states to these elements. So diatomic nitrogen, as it only has one capital letter, is elemental. So each nitrogen atom in the nitrogen molecule, we would say, has an oxidative state of 0. Carbon tetrafluoride. Collectively, carbon tetrafluoride, the carbon and the 4 fluorines, have to have a 0 charge because this is a neutral compound. However, the fluorides all produce a -1 charge. 4 of them means together we have a -4 charge. Carbon can have various oxidative states, so we have to do some algebra to figure out what carbon's oxidative state is. So something -4 has to equal 0. Carbon must be a +4. So carbon is +4, fluoride always a -1. In sulfuric acid, again, collectively the oxidative state has to be 0. Oxygen is always a -2. Hydrogen in the first column of the periodic table, we are going to assume, is always a +1. So 4 oxides means collectively we have a -8. 2 hydrogens collectively mean we have a +2. So something +2 minus 8 has to equal 0. Combining terms, we get x minus 6 must equal 0. Sulfur must be a +6. So hydrogen's oxidative state, we would say, is +1. Sulfur, we would say, is a +6. And oxygen, a -2. Dichromate is a polyatomic anion. Collectively, dichromate is not neutral. Collectively, dichromate has to equal a -2. Each oxide provides a -2 charge, so collectively 7 of them would produce a -14 charge. 2 chromiums have to equal a -2 charge when combined with that oxygen. So we get 2x equals 12. X must be +6. So chromium must have a +6 oxidation state. Oxide is always a -2. With that being said, you are able to complete number 1 on page 21 in your packet. Again, I will always provide you known oxidation states. So for each one, I provide you at least one element whose oxidation state you should know. So for example, for A, you know fluoride is always -1. For part B, you know that potassium, a group 1 metal, is always +1, and oxygen, or oxide, is always going to be a -2. I just want to draw your attention really quick to letter C. Letter C is nitrate, which is NO3 with an extra electron. So collectively, nitrate has to have a -1 charge. Please do page 21, question number 1, as well as answer questions 3 through 7 for your note quiz questions. Record your answers in the back of the packet and enter them into the Google form at the end of the video. Once we are able to identify the oxidative state of each element in a compound, we can determine what the half reactions are, as in which half is oxidized and which half is reduced, because any redox reaction can be broken into 2 parts, the reducing agent and the oxidizing agent. Before we get to all that, we have to assign everyone their oxidative state. So potassium starts as a potassium ion. Potassium being in the first column of the periodic table is always a +1. So on both sides of this reaction, potassium is a +1. Bromide must cancel that +1 out because collectively this compound has to be neutral. So bromide must be a -1. When it becomes bromine, the molecule, it has an oxidative state of 0. Chlorine starts with an oxidative state of 0 because it's elemental, but it has to cancel out potassium. It becomes chloride, so chloride must be a -1. In order to figure out what's oxidized and reduced, we will break our reaction into all of its players. So potassium becomes potassium ions. 2 bromides become a bromium molecule. Chlorine gas becomes chloride ions, 2 of them. You'll notice that potassium does not change from reactant to product. That is because potassium is what we call a spectator ion. Spectator ions do not serve a functional purpose in the experiment and can be switched out with any other member of their family. We could just as easily carry this reaction out with sodium bromide or with cesium bromide. It only is there to provide us a safe passage for that ion. Spectator ions are not part of the chemical reaction. In fact, you could remove them altogether from the reaction, producing what's known as a net ionic equation. So removing the spectator ion, let's move on to bromium. Bromide becoming bromium, the only way that could happen is if it gained or lost electrons. In order to determine if it gained or lost electrons, we have to balance the reaction, which it is already balanced by mass, but we have to balance it by charge, meaning looking at the reactants, first the products, what charge do we have? 2 times a -1 means our reactants have a -2 charge, but our products have no charge. We can balance charges in redox reactions by adding electrons, which are negative, meaning we can always bring numbers down. We cannot bring them up. So I can bring this 0 down to a -2 by adding 2 electrons. The same with chlorine. Chlorine becomes chloride by exchanging electrons in some way. Our reactants have no charge. However, our products, 2 times a -1 is a -2. Our products have a -2 charge. Again, we can only bring numbers down. So if we add 2 electrons to the reactant side, we'll take this 0 down to a -2. Now that we've balanced our charge, it's easy to see that bromide lost 2 electrons. Products are seen as being lost. So bromide, a loss of electrons, is oxidation. So bromide is oxidized because electrons are a product. They are lost. Chlorine gains 2 electrons. Electrons are a reactant, so we consider them being gained by chlorine. So chlorine is reduced. You'll notice that bromine gave off 2 electrons, which were immediately picked up by chlorine because the amount of electrons given off has to be the same. If bromine gives off 2 electrons, chlorine has to pick up 2 electrons. So the amount of electrons transferred is always the same. And with that, you are able to answer the next 2 note quiz questions in your packet. Please answer questions 8 and 9 in the back of your packet, record your answer, and enter it into the Google form at the end of the video. Let's get some more practice on this. Turn your packet to page 23, and let's do 1 and 2 together. Strontium undergoes a combustion reaction or a synthesis reaction to produce strontium oxide. In this reaction, we start by assigning everyone their oxidation state. Anything elemental, such as strontium with 1 capital letter, automatically is 0. However, when strontium forms an ion, strontium in the second column is always a +2. Oxygen, starting elemental with a single capital letter, starts with an oxidation state of 0, and when it forms oxide, oxide is always a -2. So breaking this into our half reactions, we have oxygen gas becoming oxide ions. And we have 2 strontium atoms that become 2 strontium ions. While our reaction is balanced by mass, we must balance it now by charge. Our reactants have no charge for oxygen. However, they have a -4, 2 times 2 is -4 charge as our products. In order for this to happen, in order to balance the charge, we need to add 4 electrons to our reactant side, bringing the 0 down to a -4. And now they are balanced by charge. Strontium starts with an oxidative state or charge of 0 as a reactant. As a product, we have a +4 charge. In order to balance it, we need to bring these numbers down by adding electrons. If I add 4 electrons to my product side, I can bring this charge down to 0. And my reaction is now balanced by charge. So, since oxygen gains 4 electrons, oxygen is reduced. Strontium lost 4 electrons. A loss of electrons is oxidation. Why don't you try number 2? Please pause the video and try to come up with what is oxidized and what is reduced, or show the half reactions for the redox reaction between lithium and sulfur, also known as a synthesis reaction. So sulfur gains 2 electrons and therefore is reduced, while lithium loses 2 electrons and is therefore oxidized. Reducing agents and oxidizing agents, like all agents, are actually double agents. They work for the other side. So if I ask you what the reducing agent is, it is simply the thing that was oxidized. If I ask you for the oxidizing agent, it is simply the thing that was reduced. So going back to example 1, oxygen is reduced, and therefore we would say that oxygen is the oxidizing agent. In fact, that's where it gets its namesake, oxidizing. Oxygen often is the oxidizing agent for metals, which causes rust. Strontium is oxidized and therefore is the reducing agent. In number 2, sulfur is reduced and is therefore our oxidizing agent, and lithium is oxidized and is therefore our reducing agent. Because if something is going to give up electrons, like lithium does, it will force something else to oxidize. So again, agents are simply double agents. They are the opposite of what you see. So on a multiple choice question, if you are asked what is the reducing agent, I highly suggest you scratch through that and write the opposite. Reducing agent is the thing that is oxidized. The oxidizing agent is the thing that is reduced. With that being said, you are now able to finish the last note quiz question. Please record your answer in the back of the packet and enter in the Google form. I would also like you to finish page 21. Now, for page 21, I do want to draw your attention to number 2. Hydrogen peroxide. Peroxide is the only time in which oxygen has a -1 charge. So for the remainder of this course, if at any time you see oxygen or oxide, you would assume it has a -2 charge, such as hydroxide here. Oxygen is a -2, hydrogen is a +1, so collectively they're a 1-. Oxygen in peroxide is a -1, so 2 of them would be a -2, which cancels out the 2 hydrogens, which is a +1. So again, this is an oddity, and you will not see it very often, but it is something I wanted to draw your attention to. So please finish page 21 in your packet. Next class, we will take our Unit 11 test, and this is actually the last of my tests that you will take. You'll have 25 multiple choice. You have to get 22 of them right to get 100. You also have to earn 6 of the 10 free response points. After this, we will go into SOL review. Good luck. Make sure you do your multiple choice homework.